using factoring, if it's an equation, yes, you will follow it up with teeing it up. If it's an expression, no, you will not follow it up with teeing it up. In fact, let's go back to like this one. If you were to go and tee this up and set 2x plus 3 equals 0 and solve that, we actually have to take off points. You might have factored perfectly, but you're supposed to stop there and show us that you know that factoring means just factor. If you're solving using factoring, then you tee it up to get a solution. But just factoring an expression, expressions don't have solutions. Okie doke? So that's number one, because there's nothing more, it's not aggravating, but it like kind of breaks your heart to be like, oh my gosh, they factored perfectly and we have to take off a point because they teed it up. And they gave me solutions when it wasn't an equation to solve. So that's my precursor. The second thing I'm going to talk about is what teeing it up even is. Teeing it up is a very cute phrase, but it kind of, it gets the job done. You guys remember what to do when we say tee it up. But it's definitely not proper. It doesn't really get at what's happening and why it works. Zero product property is what this is all called. The whole reason we get things equal to 0 is because when two things multiply to get 0, it tells you something very important, right? Or very helpful anyway. If two things or three things or four things multiply to give you 0, then one of them has to be 0, right? Non-zero numbers, 2 times 3, will never multiply to get you 0. So when we know that two factors, x plus 7 times x minus 3, two things being multiplied equals 0, then either the x plus 7 could equal 0 or the x minus 3 could equal 0. And if x plus 7 equals 0, then x equals negative 7. If x minus 3 equals 0 and you solve that, then x would have to equal 3. And those are your two solutions. Good? That's what teeing it up actually is. It's using this zero product property. So already in factored form, so we're going to take advantage of that. We don't have to do that work. And we're going to set each piece equal to 0 and solve. So on this first one, we have to add our 5 to both sides, divide by 2, x equals 5/2. On the second one, add 4 to both sides, x equals 4. Two factors typically means two solutions. On this one, this is an interesting one. How many factors are there? 3 factors. The 4 is a factor. 3x plus 2 is a factor, and 4x minus 3 is a factor. The issue with 4, though, is that that's a factor that doesn't contain an x, so it's not going to contain a solution. You can still say, okay, there are 3 factors being multiplied. If any one of them equals 0, I have a solution, and you can still set 4 equal to 0 and try to solve that. But what do you know about 4 equaling 0? It flat out doesn't. So that's going to be, you're not going to get a solution out of that. That would be no solutions from that one. With the 3x plus 2 equaling 0, you're going to subtract your 2 over and then divide by 3, so that'll be negative 2/3. And with the 4x minus 3 equaling 0, you're going to add your 3 over and divide by 4. So that one, even though it had 3 factors, only 2 of them gave solutions, because the third factor did not contain an x. Now, in the next section, we have to do more of the work. If we're going to use this zero product law, number 1, we have to get it equal to 0. Number 2, we have to come up with factors. So I'm going to add my 2x over. This is what we kind of have already done on very simple examples. When we were solving radical equations, sometimes quadratics came up. Oops, that happened because I switched my order of things around this year. And you knew it from Algebra 1, but now hopefully you know it a little bit better. So x squared plus 5x minus 24 equals 0. My friend Chloe already factored it. I'm not mad, I'm happy. What'd you get?
8 and 3. Well, positive 8, negative 3.
Well, what are the factors?
X plus 8 and x minus 3.
I don't know if she's right. Is she right?
Yes.
Don't sound so excited about it, Bella. Okay, so if you tee this up, aka set each factor equal to 0, x equals negative 8 or 3. Sometimes, guys, in multiple choice, and I think you guys would know this, but just in case, you'll see the solutions written in curly brackets, like as a list. You've seen that before, yes? So, all right. I'm going to skip B for a moment. I'm going to go to C. To get it equal to 0, I have to subtract my 3x over. And then to use the zero product property, I have to get this into a product of factors. What do you think step 1 in factoring would be here? Owen?
I'm going to take the cube root.
Like the difference of perfect cubes?
Yeah.
3x is not a perfect cube, though. What, Owen, should every factoring problem start with?
Greatest common factor.
Do you see a GCF?
3.
What is it?
3x.
3x, very good. Once you take that out, we're left with x squared minus 1. And so, again, once you always take the GCF out, you want to look at what you're left with and see, can that go further? What do you think, Faye? Can this x squared minus 1 go further, or is that as far as it goes? I bet people are going to disagree with you. It's a special case, 2 terms. Difference of perfect squares, difference of perfect cubes, or sum of perfect cubes. Look again. Difference of perfect squares. So this factors into conjugates, x plus 1, x minus 1. So we have 3 factors here, and all 3 of these do have an x. So we will have 3 solutions. If we tee up 3x equals 0, and we solve that by dividing both sides by 3, x equals 0 is one solution. On the second factor, x will equal negative 1. And on the third factor, x will equal positive 1. So your solutions are 0, negative 1, and 1. I actually want to go back to this step for a minute and just show you something that Faye actually still could have come out okay on this problem if she didn't notice that could be factored further. Not all problems will she get that lucky, but on this one she could, because if you just saw this as 2 factors, a linear and a quadratic, and you teed it up, you'd still get your x equals 0. And if you teed up x squared minus 1 equals 0, you have to add 1 to both sides. You'd get x squared equals 1. And then what do you do to both sides to solve that? Square root, right? And anytime you take the square root of both sides, what do you have to remember? Plus or minus. So we actually still could have gotten the same 3 answers, coincidentally, on that one, because the difference of perfect squares usually you can still tee up and get away with. But if it was like a quadratic trinomial, you wouldn't have gotten that lucky. Okie doke. Oh my gosh, Mrs. Rayhill. What did you do on D? What's the mistake on D? It's an expression, and I forgot to put an equal sign. So I'm going to throw that in there now, equals 0. And what method of factoring, Lucas Coletta?
Grouping.
Good. Everyone go ahead and group on your own. and try to finish it out. Jason, how many solutions did you get?
I got 2.
2. What were they?
3 and -2.
I think you're missing one.
No. I got that.
You got that,
Yeah.
and then you teed it up, and you got -2.
Yes.
I buy that. And you got,
I added the 9 later and took the square root of that.
oh yeah? And when you take the square root of both sides, you have to remember,
Oh, yeah.
oh yeah, what?
Wait.
Prove
Maybe
it.
not.
Prove it.
Maybe not.
Come on, Chloe just told us. Chloe, tell him again.
What?
When you take the square root of both sides, he has to remember
Plus minus.
plus minus. There, he did remember. So x equals -2. And by the way, that's if you don't realize or choose not to factor your difference of perfect squares further into x plus 3x minus 3. And then you have -2, -3, and +3. Just so you know, this is a pattern you're going to have to start realizing more and more. The degree of this was 3. That usually means 3 solutions. The degree of this was 2. I'll use here. That usually means 2 solutions. The degree of this was 3. That means 3 solutions. Not always, but most of the time. And we'll talk about the cases where it doesn't always appear that way. But any questions? Flip it over. All right. Systems of equations. This is a topic you've done, but we've typically been doing 2 linears. I think we did do a linear with a radical in the radical chapter. And every new type of function we look at, we will be doing a linear and that type of function. So we did a linear with a radical, and this is a linear with a quadratic. Yes? We're trying to find the x and y coordinate pair, or pairs, that's going to work for the line and for the parabola. So algebraically, this is going to be done by substitution. If y, and we're going to take our linear expression, the 4x plus 5. If y equals 4x plus 5, I can use that 4x plus 5 to replace the y in the other equation. So that's going to be 4x plus 5 equals 3x squared minus 8x plus 5. Substitution. And then we're going to solve. So we're going to get it equal to 0. I'm going to subtract my 4x over and also subtract my 5 over. Oh, this is nice, because my 5's are gone. And I'm going to solve by factoring. What's my GCF, Jack Taylor? 3x. And I'm left with x minus 4. That binomial is not a special case, because x is not a perfect square. So we'll just tee it up. I'll get x equals 0 from my 3x term, and I'll get x equals 4. Now, those are the 2 possible x coordinates. So right there, that tells me that this line and this parabola cross each other twice. I need to know the point at which they cross each other. Right now, I have the x coordinate of one of the points, and I have another x coordinate of the second point. Each of those has to have a corresponding y coordinate. So this is going to be 0 comma something, and this one's going to be 4 comma something. How do I find the y coordinate, Owen?
And plug it into the y equals 1.
Right. Plug it into your y equals equation. Probably the easier one would be a good decision. So if I plug in an x of 0, what's 4 times 0 plus 5? Good. So that y coordinate is 5. That's one point where they intersect. And if I plug in 4, what's 4 times 4 plus 5? 21. Now, you don't need to do this. I'll do it for you. Almost any system you're going to see on Regents is going to say algebraically. Almost any system, not all. There are some that we can do strictly on the calculator. But that doesn't mean I don't want you to use your calculator to check. And you're going to do that simply by graphing the parabola, 3x squared minus 8x plus 5, and graphing the line, 4x plus 5, and looking at the graph. There's your parabola. There's your line. We only see the one intersection, correct? That's because our other one's happening and you can kind of predict it's happening up and off our screen. If I need to see further up, do I need to change the x min, the x max, the y min, or the y max? If I want to see further up. Okay, so you go to your y what? Y max, okay. I don't know if I heard Y min. So rather than 10, by the way, I already know that it's crossing at 21 as my Y coordinate. So I'm just going to go to 25 just to make sure I see it. There's my parabola. Here's my line. I see both points of intersection. Now you can gather, because we already have the algebraic answer, that's 0, 5. But if you wanted to check, second trace is our favorite menu. Option 5, intersect. Your cursor, bring it to one of your points of intersection and just hit enter, enter, enter. It'll say first curve, second curve, guess. Just enter, enter, enter. There's your answer. To find the other one, repeat second trace, option 5, intersect, and just scroll over to the other point of intersection, hit enter, 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 421. Okie doke. Make sure your answers to systems are written as points because they're where they cross. So if you just want to sketch this real fast, it doesn't need to be perfect. That's 0, 5, and that's going to be considered 421. Systems are something we will be doing all year long. You take the linear, you plug it into the other one, whether it's a quadratic, whether it's a radical, whether it's an exponential, whether it's a log, whether it's a trig, all these different types of functions that I know you're looking forward to. Okie doke? Any questions on systems? This one just shows us a parabola and asks us to write the coordinates of the two x-intercepts. Give me one of the x-intercepts, Lucas B. -1. In coordinates, I'm just going to write -1, 0. And the other x-intercept, Sierra with an S, or Sierra with a C. And the coordinates of that would be what? 3, 0. Remember how I said with x-intercepts, you set y equal to 0? Would you look at that? Y coordinates that are 0. All right, so that was fun. Easy, right? Part B wants you to find the x-intercepts algebraically. Here we go. To find an x-intercept, you set y equal to 0. Here we're going to get to show off our factoring. And solving with factoring via teeing it up using the zero product property. And obviously, what do you notice? Your solutions for when you set y equal to 0 algebraically are the same as the x-intercepts. Yes? So in any of these problems we've been doing, go back to the front. This graph is going to cross the x-axis at 0, 1, and -1. This graph is going to cross the x-axis at -2, -3, and 3. So these are not parabolas anymore, and we'll get into that more later when they cross more than twice. But your solutions are where your graph crosses the x-axis. We follow that? You knew that for parabolas from Algebra 1, I know. And then more of the same down here. Algebraically find the x-intercept. So for any one of these, we're setting y equal to 0, y equal to 0, y equal to 0, and solving by factoring. Capiche? All right, so we'll skip those. Let me see. I'm trying to think if there's any flashcards I should be adding from this week other than those. I don't think so. So I'm just adding those for the identity proof, so I'll scan this on today.
Do flashcards repeat? Like, can you get like the same twice?
On the same quiz or 2 weeks in a row?
Like 2 weeks in a row.
Yes. Do flashcards repeat? Can you get one tomorrow that you had last week? Absolutely, because I just shuffled my deck and whatever lands on top. I thought your friend wanted to do it. No?
I mean, I really want to do it.
Kids these days, so unmotivated to learn if you're not forced. Interesting.